Thank you everyone for joining us today for this Encode Avalanche workshop. We are delighted to have the main man, Gabriel here, who is one of the big dogs. He's one of the big dogs, let's put it that way, of the Avalanche ecosystem. He is an absolute gent, but he's an even better developer, and he's going to teach you about some things to get started with Avalanche, give you a little bit of tools and tricks, a few bits of alpha for building the next generation of great things on Avalanche. This is part of our Encode Avalanche online series. This is the education component. I see some of you that were involved in our just finished coding bootcamp, where we trained you on building stuff in blockchain and becoming blockchain developers. And soon we've got a ton of stuff coming up in the next few weeks. The online hackathon will happen. Unfortunately, it was supposed to happen now. There's a big, exciting reason it's not going to happen now, which we'll announce soon. That will happen in the spring. But we will have some really cool stuff coming up, which I hope to see all of you at very soon. Last thing to say, you'll get an NFT for taking part in this event, which you'll have. Please keep that NFT. It will mean something, I promise you, at some point. So that sounds very vague, but keep that NFT. As that you will get one for every event you come to with Encode Avalanche. So without further delay, Gabriel, we're in your very capable hands. Take it over, sir.
Excellent. Thank you so much for having me, Anthony. Hey, everybody. Thank you for having me. As he mentioned, my name is Gabriel Cardona, and I am developer evangelist.
I can't hear you.
You cannot hear me?
Now I can. Yes, go ahead.
Okay. Yes. So I'll repeat. Thank you for having me. It's a great honor. My name is Gabriel Cardona, and I'm developer evangelist at Avalanche. And today we're going to be giving a high-level overview of the Avalanche Developer Toolkit. So this will basically include different libraries and services which are available to you as a developer in the Avalanche ecosystem. So let me share my screen. As I mentioned, my name is Gabriel Cardona. I'm developer evangelist from Avalanche. And so I have the incredibly fortunate and cool job of going around the world to different meetups and conferences and conventions. And I give presentations hoping to inspire people to build amazing dApps on Avalanche. You know, why do I do that? Why am I so incredibly passionate about this? Well, I personally believe that the most valuable asset on the entire planet at this exact moment in time is a competent, hardworking, and creative developer. And so I believe that if you zoom out, if you zoom way out and take the 10,000 foot view of, you know, where we are in the evolution of our species, I would say that we are just now beginning to really see the glimmer and the promise of the potential of humanity. We have so much that we could potentially do, and we're just now starting to see what we can do. But I also think that we have big problems that we need to solve at scale and velocity. And so fortunately for us, there have been so many paradigm shifts in computer science and engineering. If you go back a couple hundred years or so, back to Ada Lovelace and Charles Babbage and the difference engine and the analytical engine, like Victorian era steampunk computers with cranks and gears. So if you go back to them and you roll it forward to where we are now, there have been so many paradigm shifts in computer science and engineering that we really are in a fortunate position of having a toolkit, which is really unlike any time in all of human history. And so now what we need is we need competent and creative and hardworking people to really step forward and build this, the systems which solve the problems. And so I say this all the time. I'll say it again probably before the presentation is over. There has never been a greater time in all of human history to have a really big idea, to find a like-minded group of people and raise some capital, to launch a game-changing app, to change the world in a big way and to make a fortune. And the amount of capital, both human capital and actual financial capital required to launch a startup has just been rapidly decreasing. So, you know, what 10 years ago might have cost $1 million, but to launch, even though some of this tech wasn't even available, right? It's great deep learning and solid consensus for blockchain. Some of this stuff didn't even exist, but for the stuff that did exist, what 10 years ago may have cost $1 million and what, 5 years ago may have cost $100,000, you can now launch for tens of thousands of dollars. And the software stacks that we're using and the libraries and the APIs, they are so incredibly high level now. They're so powerful. The economy of expression is so great that it just simply requires less engineers to write and maintain these amazing systems. And in addition to that, these platforms that we're all using, they're either open source, in which case they are completely free, both gratis and libre, right? Free as in speech and free as in beer. or they have a free tier, which brings the cost of shipping an MVP way, way, way down. And then in addition to all of that, Web3 has value as a native primitive. And so, it's very much in vogue today to raise capital with an initial coin offering, or you can even do yield farming. There are many different ways in Web3 to actually generate capital. And then even in addition to that, there are so many successful blockchain entrepreneurs. We consider Avalanche to be blockchain 3.0 technology. We think of Bitcoin as 1.0, Ethereum as 2.0. And so there have been very, very many successful entrepreneurs from the 1.0 and 2.0 eras who have, had liquidity events, and now they're looking for ways to put that capital to work for them as investors in the next amazing idea. So there's just a lot of ways to get capital. It's never been easier. And so the story that I like to use to kind of illustrate the point is the very first job I had out of college, I was at Trulia.com, and we went public on the New York Stock Exchange. We had an IPO, and it took us around, our CEO, Pete Flint, he did like a tour across the United States. He did a road show where he had to go meet with all these big wigs in all these different cities. He had to, wine and dine them. He had to press the flesh. We had to hire an entire team of Silicon Valley finance lawyers. I think we had 4 or 5, plus they have all their hangers on, of course. The entire process was very much wrapped in red tape. It took about 13 months to complete. And when we went public, Pete got to ring the bell on the New York Stock Exchange, and we raised $102 million in that IPO. Now compare that with creating a token on the C chain and launching an ICO or an IDO. You can raise $100 million in one afternoon. The pace at which capital moves in Web3 is truly shocking. And the very last point I'll mention here is that everybody also all around the world is just super wired in, and ideas spread nearly instantly. So, the amount of time between the introduction of a new technology and when it goes mainstream is decreasing. So we should continue to see amazing ideas catch on like wildfire. So there's just never been a better time to try and have a big idea, find people, and change the world. So now I do want to just touch on the different components that are available for developers in the Avalanche ecosystem. So I think the first place we want to start, of course, is with AvalancheGo. AvalancheGo is the reference implementation of an Avalanche full node. Of course, as you might get from the name, it is written in Golang, and it contains the full breadth and functionality available on the Avalanche platform, including what's known as the primary subnet, which consists of our XP and our C chain. And there's a JSON RPC for each chain, right? So of course you can read and write data to and from the blockchain using the JSON RPC. You can create variable and fixed cap SecP 256K1 assets. You can create non-fungible tokens. You can of course stake your AVAX as a validator or a delegator. The difference being a validator is a full, you have your node be a full block and vertex producing node, where with delegating, you can actually delegate your stake to a validator and you increase their weight with regards to sampling. You can also create new subnets, which are tailor-made networks with custom virtual machines and complex validator rule sets. You can instantiate virtual machines as blockchains on your subnet. You can even swap assets between the different chains. So we have built into our protocol the ability to move assets between the X, the P, and the C chain. Coming in a very in a soon network upgrade, you'll be able to swap assets even between the different subnets. It's built into our API. And so in addition to those things, the full node also has a key store API. And so the key store API enables you to store your keys on the full node. We consider this an anti-pattern actually, because you're putting private keys out on a box that's on the web, and so of course it's just a target for hackers or malicious people. So we consider it an anti-pattern to store your keys on the key store. Instead, we suggest and recommend that you create and sign transactions locally using a tool like AvalancheJS. So we suggest that you keep your you have a mnemonic, right? So you have a human readable mnemonic which represents a source of entropy, and then you can deterministically derive a hierarchical tree structure of keys all from this mnemonic, and you can do that all locally using a tool like AvalancheJS. That's the pattern we suggest. A couple other things. So if you're familiar with Unix systems, you may know that a tilde represents your home directory, and that also if you put a dot at the beginning of a directory name, it will make it a hidden directory. So if you check out tilde /.AvalancheGo. So there's a hidden directory called AvalancheGo in your home directory. And inside that .AvalancheGo directory, you will find a staking directory. And inside that staking directory, you will see a TLS certificate and a private key. So Avalanche uses transport layer security, or TLS, to protect node-to-node communication from eavesdroppers. TLS combines the practicality of public key cryptography with the efficiency of symmetric key cryptography, which has resulted in TLS becoming the standard for internet communication. And whereas most classical consensus protocols employ public key cryptography to prove the receipt of messages to third parties, the novel Snow consensus family does not require such proofs. And this enables Avalanche to employ TLS in authenticating stakers, and it eliminates the need for costly public key cryptography for signing network messages. And we have TLS certificates. So Avalanche does not rely on any centralized third parties. And in particular, it does not use certificates issued by third-party authenticators. All certificates used within the network layer to identify endpoints are self-signed. And this creates a self-sovereign identity layer with no third parties ever involved. And we also have TLS addresses. So to avoid posting the full TLS certificate onto the platform chain, the certificate is first hashed. And for consistency, we employ the same hashing mechanism for the TLS certs as what is used in Bitcoin. So namely, the DER representation of the certificate is first hashed with SHA-256, and then the result is hashed with RIPE-MD160, and it gives us a 20-byte identifier for the stakers. And this 20-byte identifier is represented as the string node ID dash followed by the data's CB58 encoded string. So what is CB58, you may be asking? If you're familiar with Bitcoin, you may know about base 58 check. So it's a base 58 encoding with a checksum. CB58 is also a base 58 check encoding with a checksum. CB58 is also a base 58 encoding with a checksum. It differs slightly from base 58, confusingly so. In CB58, we only SHA-256 one time instead of twice, and we use the first 4 bytes as the checksum as opposed to the last 4 bytes, which is base 58 check. Yes, I admit that's confusing. I wasn't around when that CB58 was introduced. If I had been, I would have lobbied very hard for us just to use base 58 check. If all we need is a base 58 encoding with a checksum, that already exists. But there's no question about it. Every single team that I've helped on ramp into the ecosystem, which has been doing transaction serialization, has universally reached out to me and been like, what the heck is CB58? Yeah, it's like base 58 check, but with those slight differences. Currently, AvalancheGo is the only full node implementation on the Avalanche network, but of course, our intention is for there to be a rich and diverse ecosystem of full nodes. And the analogy that I like to use is with the web and different web browsers. So of course, way back in the day, there was just, Internet Explorer and Netscape Navigator, and there were no official standards. There was no DOM standard. There was no HTML standard. And the different browsers would reverse engineer functionality from each other. And it led to this really horrible world where developers had to tease out the browser from a user agent string and then have all these different if else statements to serve up, different JavaScript code depending on what the user agent string was. And then you would have little pictures at the top of each web page that said this page works best in Netscape Navigator 4 or Internet Explorer 5. It was a pretty bad deal. And if you compare that today, where we have the World Wide Web Consortium and we have DOM API and HTML5 API and CSS and ECMAScript and everything is very standard. And then we have different implementations, right? So we have all the different major browsers, Internet Explorer and Edge, Safari, Chrome, Firefox, Opera, and the long tail of different browsers. And so today we live in a world where we have a standard and then we have multiple implementations of the standard. And that's always good because the multiple implementations are able to suss out different edge cases and different bugs. We envision the same kind of world in the Avalanche network. What we would like to see is some type of formal specification and then multiple implementations of that specification. And similar to how browsers, Chrome and Safari, well, why do you need each one? They both are just rendering a web page because they both have their own special sauce with regards to the user interface of the browser and that kind of stuff. So in addition to just rendering the specification and implementing it, you can add your own special sauce. And we would like to see something similar with regards to Avalanche full nodes. So we hope in the future there will be a very rich and diverse ecosystem of full nodes. For firing up a local test or private network for development, so something akin to Ganache, if you're familiar with Ganache from Ethereum, we have what's called the local network runner. and it's a tool to interact and it's a tool to run and interact with an Avalanche network. So to some of you out there, I hear you saying, but what about Avalanche? So yes, that is very insightful of you, very perceptive. Avalanche has basically been sunset in favor of the local network runner. Avalanche was actually created a long time ago. It was created before the mainnet went live, and it was originally architected by an intern who, to be fair to that intern, is an amazing engineer, and he went on to work at Google, but so much has changed since that app was, originally envisioned and created. And so we've been talking about doing a complete rewrite from scratch, and ultimately that's what happened here. And the result is the local network runner. So we are officially sunsetting Avalanche, and we're welcoming the local network runner. So in the context of configuration, using I'm going to call it the LNR, that's the local network runner. So using the LNR, when you create a network, you specify the configurations of the nodes that are in the network upon creation. And not only properties such as the node's name and staking certificates and private keys are configurable, but also configuration which is specific to the type of network being used. So for example, a node running in a Kubernetes cluster has a config field that specifies the Docker image that the node runs, whereas a node running locally has a config field that specifies the path of the binary that the node runs on. And regarding Genesis creation, you can create a custom Genesis which enables configuration of balances and airdrops and reward addresses. You can even put in a custom Genesis message. So in our Genesis block, when we launched Avalanche, we have from Snowflake to Avalanche and through consensus to the stars. That's where those phrases came from. They're actually in the Genesis block of Avalanche. You can do the same thing yourself with a custom Genesis creation. The local network runner implementation includes a predefined configuration, which allows you to create a new network without needing to define any configurations. So this is how you quickly spin up a 5-node staking network with the pre-funded well addresses similar to Avalanche. So if you've been using Avalanche, you know that we have a private key there, which is a well. And that way, when you're firing up your local network and you're doing testing, you have this AVAX that you can use. The same functionality exists on the LNR. So we have a default network which you can fire up. It's 5 nodes, it's staking, and there's the well address. As an example of how to use LNR, we've included a main.go file that uses the local implementation of the network runner. So when you run it, it first creates a local 5-node Avalanche network, and it waits for all the nodes to become healthy. Once it gets back a healthy call from all of them, it actually prints the name of each node. Then it'll actually print the node ID of a single node. This is just demonstrating the functionality that you can query at the network level and at the individual node level. It then fires up a 6th node. It removes one of the original 5 and swaps in the 6th. So again, this is kind of a demonstration of how to do a local network, how to query the APIs at the network level and the node level. So this exists now. And of course, the network will run until you provide a SIGINT or a SIG term. So if you're doing local development, I suggest that you take the afternoon or whatever and transition out of Avalanche and into using the local network runner. Next, we have a Postman Collection. Postman is a platform for building and using APIs. It simplifies each step of the API lifecycle and streamlines collaboration so you can create better APIs faster. And if you're a modern web developer and you're building REST APIs, gets and post and puts, HTTP verbs with JSON response bodies, and you're not using Postman, then I really, really highly recommend that you, again, take the time required to on-ramp your skills into Postman. Some things that the Postman collection can do is you can set different key value pairs for different environments. So, if you want to use passwords or something like that, you can have a localhost environment, a Fuji environment, and a mainnet environment, and you can have the respective key value pairs, and then you can pull them out into the different requests. It gives you the code snippets for requests and responses. You can put in documentation. You can change the different HTTP verbs. So if you guys are familiar with REST, representational state transfer, you're basically mapping the CRUD operations of a database with HTTP verbs, right? So you have CRUD, create, read, update, delete. You map create with post, read with get, update with patch or put, and then delete with delete. So it's a really convenient way to map HTTP verbs with CRUD operations. You can change the different HTTP verbs using Postman. You can change the request and response type. You can get the response HTTP code back. So if it's a 200, it's a 404 or 500, you can get the how long it took, the size of the response. Postman is incredibly powerful. And again, if you're working with modern REST APIs and you're not using this, then I assure you this is going to make your workflow just so much easier. And I suggest you take the time and check it out. Next is our documentation. So, we realize that the canonical answer to any question regarding how Avalanche works is to read the manual, right? That's the classic joke, read the manual. But it's really true, right? So with that in mind, we have exhaustive and up-to-date documentation. We spend a ton of time on our docs. Of course, it's open source and it's all written in Markdown. So we encourage everybody at AvaLabs, literally, we encourage every single team, whether you're an engineer or not, to contribute to this if they feel the desire to do so. Markdown is very easy. Anybody can pick it up over the course of, just a few minutes. So, pardon me, we encourage everybody. If you see the docs and there's something you want to change or add, do it. And so, of course, we want to, extend the same thing to the community. If there's anything you see out there that you want to make a change, do it. This is a living document. It's the canonical source of all truth for our ecosystem, and we want to keep it up to date. So if you see something which is out of date or could be improved, please fork the repo, make the change, and create a pull request. I am of the opinion that updating documentation remains the single easiest way to contribute to an open source project. It's a great way to connect with the team and to help move the project forward while building social equity with the team. So, speaking firsthand, having created many open source libraries in my career, I have a genuine appreciation of the importance of quality documentation. And so my very first week on the job at AvaLabs, I immediately started improving the docs. I found errors or stuff that was out of date and I fixed it. I created some new tutorials. I ran the entire code base through a markdown linter and I made a bunch of suggested changes to clean it all up. There was even a moment when I alphabetized a bunch of the JSON RPC calls. I just put a bunch of love into the documentation. So eventually Dan Lane, who's one of our amazing platform engineers and who was the primary owner of the repo at the time, was just like, give Gabriel editor permissions to the docs repo. So, just speaking firsthand, I can, let you know that if you show up and you start throwing energy at the docs, it is just an incredibly great way to push the ball forward, to help out the team and to build social equity. Our docs have release notes for AvalancheGo. There's also an Avalanche Notify service, which monitors all the validators on the network and sends an email alert to a validator's subscribers if it becomes unresponsive or is out of date. The reason this is important is because an unresponsive validator risks losing their potential staking rewards if their observed uptime is less than 80%. But just for super clarity, Avalanche does not have slashing. So a validator's stake is never at risk. It's only their potential staking rewards which are at risk. The docs have many tutorials. You can run and back up and restore a node, create a multi-node local test network, create and transfer fungible and non-fungible tokens, run smart contracts. And of course, our intention is to have tutorials for all of the functionality on the network. And so we have actually recently started scaling up the developer relations squad, which is the squad I'm the lead of. Our most recent teammate who just joined a couple weeks ago, his name is Raj Ranjan from India. He was actually the winner of a recent competition to create tutorials. You may or may not remember, but we recently had I believe it was $50,000 US in prizes for a competition to build and improve the Avalanche documentation. And I think he won 3 or 4 of those. And then we reached out to him to see if he wanted to join our team because he just did such great work. So the quality and quantity of our docs are going to be improving rapidly this year. It is a primary focus for the developer relations squad, and we're actually hiring people specifically for that. Speaking of which, here's some alpha for you. We are actually hiring one more role for the developer relations squad. So the squad that I'm the lead of, we're trying to fire one more person right now. Ideally, I apologize. Ideally, you would be a technical writer. If you're interested, please hit me up. I'm going to share my contacts at the end, but we are definitely looking for another person to add to the developer relations squad. So if the stuff I'm talking about today seems cool to you and turns you on, feel free to reach out to me. The docs have the JSON RPC for the X, P, and C chain, and we do not document the entire EVM JSON RPC since it's already documented elsewhere, like on Geth, for example. For the EVM, we only document the Avalanche-specific JSON RPCs, such as get atomic UTXO for cross-chain swaps or import AVAX again for cross-chain swaps. There's several, but we do not document the entirety of the EVM JSON RPC because, as I mentioned, it's documented exhaustively in other sites such as Geth. We've also documented all the serialization specs. So back up here. A virtual machine is a state machine, and you have the state of your blockchain, and then you have a state transition function, and you can trigger the state transition function through transactions. So there's many different transaction types, transactions to create assets, transactions to add subnets, transactions to swap assets in and out of different chains. And so we have all of that documented, the serializations. And if you are writing your own library, then you can use these serialization specs to create the transactions which trigger the state transition function on the different blockchains. And all of that stuff is implemented in AvalancheGo and AvalancheJS. So if you wanted to go and look at the transaction serialization spec and then compare it to an actual implementation, you can go check out AvalancheGo or AvalancheJS. We also have the white papers. We have white papers on the platform, Avalanche consensus on the AVAX token. There is even a white paper on a classification framework for stablecoin designs. It's a very interesting read. I suggest checking it out. And then lastly, we have some of our audits. We don't have 100% of our audits. We weren't able to put some of them up there, but some of our audits are up there. And then there's even more than that. And then lastly, we of course appreciate that the blockchain is worldwide and not everybody in the world speaks English. So we have a focus on internationalization with French, Japanese, Turkish, Spanish, and Chinese simplified docs are in the works right now. We've already got PRs. We're just ironing out some of the details, and then we want to have more languages in the future. So very important to us to be able to communicate with people all over the world and to, show them the courtesy of attempting to communicate with them in their native tongue, as opposed to expecting them to just know English. Next is AvalancheJS, which of course is near and dear to my heart because this is the library that I personally maintain. And it is a TypeScript library for interfacing with the Avalanche platform. And it's built using TypeScript, and I'm a huge advocate of TypeScript. And if web tech touches your workflow, and I suspect that web tech touches nearly everyone's workflow, then you absolutely must take the time and on-ramp your skills from JavaScript to TypeScript. So let me give you my elevator pitch on TypeScript real quick. Why TypeScript? Okay. Over the history of programming languages and APIs, we have seen two patterns repeat ad infinitum. We've continuously gone from programming in the small to programming in the large, and we've continuously gone from programming with low-level abstractions to programming with higher-level abstractions. And you can be absolutely positive that whatever you today consider to be super high-level and super huge will be thought of as low-level and small by the next generation of engineers. The same exact patterns keep repeating. Why do they keep repeating? Because we're living during what is perhaps the most unique phenomenon in the history of the universe, and I'm not overselling it here. We're living during this exponential growth in the power of computation and digital systems. It's incredibly unique to our time and our place in the universe. And so colloquially, we call this Moore's Law, right? That's what we call it across sort of popular cultures, Moore's Law. But, we're all engineers here, so most of us might know that, Moore's law is really related to fitting transistors on an integrated circuit. And there's in fact so much more that's going on there. There's only so much that we can do with regards to more transistors on an integrated circuit. Some people might be thinking, yeah, but Moore's law is dying. That's the phenomenon I'm describing here. We're getting down so small, we're at the nanometer scale, and we're suffering from quantum tunneling. So we're literally running up against the wall of what is possible with the physics of our universe. We might start building chips into the third dimension. Our brains are in 3 dimensions after all. We might go to quantum computing. We might have more clever algorithms. We might have computers get more parallel instead of faster, but there's no question about it. We're going to continue to see the pace of change and accelerating. And the way I think about it is all this technological change is really complexity that you and I as system designers have to tame. So it's all good to say the pace of change is accelerating. We're going to see all this new radical progress, but we're the people who have to build the systems which, make that happen and are sustainable over these years. And so if you think about complexity like a sphere, so visualize this with me, complexity is like a 3-dimensional sphere, and it's growing in all dimensions exponentially at all time. And it is our job as systems designers to always have a solution space that is at least large enough to encapsulate the complexity or the problem space. So picture the sphere, that's the problem space. We need a solution space which is at least big enough to encapsulate that. So picture like a cube, encapsulating a sphere, right? The sphere is the problem space, the cube is the solution space. At any moment, the complexity could grow by an order of magnitude, right? So the sphere can blow up at any moment. And it's on us, again, as system designers, to ensure that we have the tooling required to tame the growing complexity. And that's why we're witnessing the same two patterns that I mentioned over and over about languages going from low to high and code bases going from small to large. It's because we are always creating new tooling with which to tame the ever-growing complexity. So to bring it back to TypeScript, JavaScript was literally created in 10 days. I don't know if you guys are aware of this, but it was literally created in 10 days. And this was created back in the 90s. At the time, obviously, no one, they may have envisioned it, but they weren't 100% sure that the web was going to become as ubiquitous as it has become. And since JavaScript is the object-oriented programming language, which ships with the web, all of a sudden JavaScript became the problem of every single engineer in the world, because all of a sudden the web is so ubiquitous, we're all dealing with JavaScript. Now, as you know, there's been a total renaissance in JavaScript over the last 10 or 12 years or so, starting from Node.js until now. There's just been a bunch of innovations which have made JavaScript more palatable, and it's really culminated with TypeScript, in my opinion. So TypeScript was created by Microsoft with the intention of being JavaScript for programming in the large. And you can kind of think about it like JavaScript 2.0. So TypeScript gives you, additional APIs to really express your abstractions so clear that they don't buckle under their own weight. It brings your IDE to life with IntelliSense. So you get code completion, error detection, perimeter info, member lists, quick info. It catches errors at compile time instead of runtime, and so much more. So that's my pitch on TypeScript. You can tell I really care about it, and that's really because I care about quality software, especially in the context of value-bearing crypto networks. So if you were to work on my team, for example, you'll definitely be using TypeScript. If you ever hand me any code to review, I will literally refactor it and hand it back to you as TypeScript. TypeScript has been so incredibly valuable to my web dev skills that it is really a one-way door, and I'm unable to walk back through that door. So in the context of AvalancheJS, AvalancheJS is written in TypeScript and it's isomorphic. So it means it runs on the client and the browser as well as Node.js in the server. And it lets you issue commands to an AvalancheGo full node in the APIs. So currently we support the admin, auth, health, index, info, key store, metrics, and socket APIs. We have a WebSocket API for real-time data. And then we also have the AVM API, the EVM API, and the platform VM API. So the full breadth of Avalanche functionality is available over AvalancheJS. And AvalancheJS is really a high-quality code base. We put some serious love into it. Obviously, it uses extensive TypeScript with classes, interfaces. We use types on every single variable and return value. We use async and await. Instead of promises, we use import statements instead of requires. We use constants instead of the var keyword, all the good things. There's also 80% plus test coverage. If you ever create a pull request for AvalancheJS, we ask for corresponding documentation and test coverage. And so, as I mentioned, AvalancheJS empowers developers to do the full breadth of functionality that's available on the Avalanche network. Next, we have the Wallet SDK. And again, the Wallet SDK is a TypeScript library for creating and managing non-custodial wallets on the Avalanche network. It provides high-level methods for transacting on the X chain, P chain, and the C chain. The Wallet SDK supports 4 types of wallets. So there's a singleton wallet. This is when you have a single SecP256 K1 ECDSA key pair. There's ledger wallets. You can actually use the Wallet SDK to interact with the ledger hardware wallet. There are mnemonics or HD wallets. So as I mentioned, you can have a mnemonic, which is a human readable string, which represents some source of entropy. And from that, you can deterministically derive a tree structure of key pairs, which is incredibly powerful. This is the industry standard and what we recommend for everybody. You can create mnemonics with AvalancheJS, and you can use the Wallet SDK to derive them. You can also create extended public key wallets. So an extended key is like the root of a branch in the tree structure of the HD wallet. And with the root of the branch, you can derive the rest of the branch. The extended public key can only create a branch of public keys. There's also extended private keys as well. And so, again, using the Avalanche Wallet SDK, developers can receive and send tokens and NFTs, transfer funds between chains, add a node to the validator set, delegate stake to a validator, create a key store file, get the transaction history of a wallet, mint NFTs, and so much more. Next is Avalanche is backwards compatible with the EVM. So one of the reasons for Avalanche's meteoric rise over the last year, a little bit less than a year and a half, has been that our C chain is 100% backwards compatible with existing EVM developer tooling. and workflows. So devs literally just need to add Avalanche as a new network on their existing workflow, and things just work. So you can see here I listed Open Zeppelin, Truffle, Hardhat, Remix, MetaMask, all of the tooling that you're used to in the Ethereum or any EVM ecosystem, to be fair, just works out of the box with Avalanche. And you can see here, I put the mainnet, Fuji, and the testnet settings. So, you can see you just add the chain ID, you plug these values into MetaMask, and MetaMask is automatically connected to the Avalanche network. We also have a smart contract Quickstart. So the goal of the smart contract Quickstart was to lay out a best practices regarding writing, testing, and deploying smart contracts on Avalanche's C chain. And we built the smart contracts we built the smart contract Quickstart using Hardhat. So you may be familiar with Hardhat. It's a development environment. Truffle is another one. We internally prefer Hardhat over Truffles. That's why we used it, but Truffle is amazing as well. Truffle also works with Avalanche, but the smart contract Quickstart is created with Hardhat, and it gives you the basic everything you need for writing, testing, and deploying smart contracts on Avalanche. And we even have some examples in there. So we have an ERC20, which is a fungible token, and an ERC721 non-fungible token example, and they extend the industry standard Open Zeppelin contracts. So we're big fans of Open Zeppelin. They have battle hardened and security audited contracts, and you can extend them. And so we've done that here in the smart contract Quickstart. We have fungible and non-fungible. We also have a storage example that shows how to read and write a simple value to the blockchain. Next, virtual machines and subnets. So you probably know this, Avalanche just isn't a single blockchain. It is a network of subnets and blockchains. And every single subnet that launches is really going to be its own paradigm. So it's going to have specific and unique tooling and documentation and teams. And it's really going to be exciting. Every single subnet is going to be its own universe. And recently we actually launched a new subnet. So, people are saying like, when are subnets going to be start popping off? There's one that went live last week. It's called Spaces. So Spaces is an authenticated hierarchical key value store. It has EIP 712 compatibility, state expiry, and fee-based metering. So go check out trispaces.xyz, and you can get a sense of, this is not a Solidity smart contract. No, this is a virtual machine and subnet that was written specifically for Avalanche. It's incredibly cool. You got to go check it out. So there's a bunch of tooling around creating subnets. So we have AvaSim, which makes it easy for anyone to spin up a local instance of an Avalanche network to interact with. The standard APIs or to test their own custom VM. We have the subnet EVM. So subnet EVM is the virtual machine that defines the subnet contract chains. And basically it's a simplified version of Core ETH, which is the C chain. And this chain implements the EVM and supports Solidity smart contracts, as well as most other Ethereum client functionalities. So if you want to launch your own instance of the EVM, you can do that now using the subnet EVM. And we think this is going to be very popular because there's still a lot of teams that are launching their own layer one networks that are forks of the EVM. Well, going forward, it makes way more sense, instead of launching your own fork of the EVM on your own layer one, you should launch it as a subnet on Avalanche. And then you get all of the special sauce out of the box, and you can have cross subnet asset transfers and all these great things. And you get Avalanche consensus, of course, out of the box. And then instead of having your own layer one network, which is very bespoke and is unable to really, tip and go mainstream, you would be part of the Avalanche ecosystem, and you're going to get all that juice. We have the timestamp VM. So this is like a proof of existence service. It defines a blockchain that is a timestamp server. So each block in the blockchain contains the timestamp when it was created and a 32-byte piece of data that we call the payload. And each block's timestamp is after its parent's timestamp. So Goon, who's our CEO, and Connor, who's the head of our dApps team, worked together in 2015 building one of the very first dApps ever. It was like a notary public service using Bitcoin, and it was basically the same thing. They could take a hash of a document, put it on the blockchain, and later, if you needed to prove you had that document at that time, you could hash the document again and compare the hash with what was written in the blockchain. That exact same functionality is what this is. So this is like a proof of existence service called the timestamp EVM, or this timestamp VM, I should say. We also have the Avalanche virtual machine. It's a DAG chain. So we have two different types of chains on Avalanche. You can have a DAG, which is a directed acyclic graph, and it has partial ordering. You can also have a linear chain, which has total ordering. The Avalanche virtual machine is a DAG, so it has partial ordering, and it's best suited for commutative transactions like peer-to-peer payments or simple token transfers. The AVM is parallelizable, it's prunable. It's actually UTXO based. If you're familiar with, there's two different models. There's UTXOs and there's accounts. The Avalanche virtual machine is UTXO based, and it's also extendable via what are called feature extensions. It's very general purpose, and you can plug in additional functionality and feature extensions. So today it has 3 feature extensions. It has SEC P256K1 fungible fixed and non-fixed cap assets. It has non-fungible tokens, and it has what are called properties, which allow you to add a key value pair to different addresses. It's one of the ways with which you could say every single address that is a validator on my network has to have like an associated KYCAML check or something like that. And but you can add in different feature extensions. Imagine plugging in, you know, post-quantum safe cryptography, or plugging in BLS signatures, or plugging in Schnorr signatures, or, you know, the list goes on and on. So the Avalanche virtual machine is incredibly cool. And then we've got tutorials, you know, create a virtual machine, create a subnet. Okay, so the public API, there is a public API server that allows developers to access the Avalanche network without having to run a node. So you may just want to use the JSON RPC, and you don't want to have the headache of actually, you know, dealing with a node, and that's understandable. That's what the public API is for. And it's actually several AvalancheGo nodes behind a load balancer to ensure high availability and high request throughput. The public API server is api.avax.network for the mainnet. Fuji testnet is api.avax-test.network. And you can just append, to access a particular API, you just append the relevant API endpoint. So for example, to use the X chain, it would be api.avax.network/ext/bc/x. And requests to the public API server are distributed by a load balancer to an individual node. And as a result, consecutive requests may go to different nodes, and this can cause issues for some use cases. So for example, one node may think that a given transaction is accepted, while another node, the transaction is still processing. And you can work around this. You can use sticky sessions, and this allows consecutive API calls to be routed to the same node. And sticky sessions are supported over a curl request, or you can also use AvalancheJS as well. And the usage of the public APIs is free. It's available to everybody without any authentication or authorization. There is rate limiting in place, but many of the API calls are cached, and the rate limits are really, really high. So if your application actually runs up against the wall, which I don't know that any are at this exact moment, we serve billions and billions of requests from this API. I don't know what the public numbers are, but it's billions. It's a huge, huge, huge number. If your application actually runs up against the wall of rate limits, let me know and we can work something out, of course. Next, we have Faucet. So as a developer, you'll need funds to test your dApp on the Fuji network. And to get funds, we have a Faucet, which gives a drip of AVAX on the X or C chain, depending on which address you paste in there. And drips are limited to 1 request per hour. So we do rate limit there. So, you know, we suggest you make the most of each drip so you don't find yourself in the situation where you have to wait another hour. And if you find yourself needing larger amounts of Fuji AVAX than are practical to get over the Faucet, reach out to me and I can hook you up. I'm a whale on the Fuji network. There's also, if you're developing on your local network using the local network runner or Avalanche in the past, we have what's called the EWOC key. The EWOC are the first 4 letters of the CB58 encoded private string, private key, I should say. And then that EWOC key is a whale on your local network. So if you're doing local network development, you can use this one private key and you can get as much test AVAX as you need locally. There's also the web wallet. So as you know, a critical part of any crypto user experience is, of course, the wallet. It lets you store and send and receive tokens and interact with smart contracts. Our web wallet is, of course, open source, and it lets you send on the X or the C chain. You can also earn by staking your tokens. It enables cross-chain swaps for moving AVAX between the XP and the C chain. There is an NFT studio for creating non-fungible tokens. You can manage the HD keys. So, you know, I mentioned you can deterministically recreate a big tree structure from the mnemonic. You can actually manage that so you can see your past, your present, and your future derived addresses. You can even sign a message with a private key to prove ownership over an address. So for example, if you have an address and it has a certain amount of AVAX behind it and you want to prove you own it, you can have somebody come to you and say, you know, sign this message, and they can give you a custom message with a timestamp or whatever, and you can sign it and verify ownership over an address, which is incredibly, incredibly powerful. So, a block explorer is another critical part of the crypto user experience. It enables you to drill down and see the historical and real-time data of the blockchain. So this includes blocks, transactions, addresses, even smart contracts. We have a couple explorers. We have Snowtrace, which you can see right here on the screen. Snowtrace is actually an instance of Etherscan, which was created by the Etherscan team, but specifically for the Avalanche C chain. So it's really, really nice. If you're familiar with Etherscan, it's the biggest block explorer in the Ethereum ecosystem. Basically, we have our own instance of Etherscan called Snowtrace. It was written and created by the Etherscan folks, but it's specifically for the Avalanche C chain. It's incredibly slick. And we also have our own explorer, which is for the X chain and the P chain. And we have there's a bunch of third-party explorers. One of them that's worth noting is the AvaScan Explorer. It's incredibly high quality. Those guys and gals are great. I love them. And then lastly, I wanted to give a little shout out to the funding. There's different avenues to get funding in the Avalanche ecosystem. We have Avalanche X, which is a grant program. So this is for moonshots. We have Avalanche Rush, which is an incentivization program. This is for getting, existing blue chip dApps from other ecosystems and incentivizing them to migrate to Avalanche. And then we also have Avalanche Blizzard, which is an ecosystem and an infrastructure investment platform. And so, if you're looking for funding, we have multiple avenues of funding. So it's worth checking those out and digging in a little bit more. And so I just want to say thank you. I really do want to express gratitude to Anthony and the Encode Club folks. You guys rule. You do so much for the ecosystem. I don't think we even understand yet how big the impact you guys are having. It's like something that's going to play out over years. So absolutely amazing work. Of course, I want to express gratitude to the AvaLabs folks. You guys are amazing. Thank you for the opportunity to be on the team. My name is Gabriel Cardona. I'm developer evangelist. You can hit me up, CT Cardona on Twitter or Telegram. Feel free to reach out. I have a ton of inbound messages. So if I don't hit you back immediately, please bear with me, but I really do try and reply to everybody. And so I think we have a couple minutes left for questions, if you guys want to do that.
Absolutely. You've got quite a lot of questions.
Yeah.
What languages do I need to know to write smart contracts on Avalanche? That seems nice and answerable.
Yeah, that's a good one. Yeah, wonderful. So the amazing thing about Avalanche is that, so there's multiple answers to this. If you were writing smart contracts for our C chain, which is an instance of the EVM, you would be using anything that works on EVM. So probably Solidity, but there's also Viper. I don't know if Viper, it might be a dead language now, but there's multiple languages which compile down to the EVM. I think Solidity is the most popular. But as I mentioned, Avalanche is a network of networks, and we're launching different subnets, which are entirely new paradigms that are not related to Ethereum. And so I think a better way to answer it is to write a virtual machine. Obviously, AvalancheGo is written in Go, but we have a gRPC API, and then we have a virtual machine that is called the gRPC VM, or I'm sorry, the gRPC chain VM. And if you have a language which can implement this gRPC API, which nearly all modern languages have a gRPC library, then you can actually write your virtual machine in any language you want, as long as it can implement this gRPC API. So we expect to see, Rust and C++ and anything that has a gRPC API.
Let us go for, what is your favorite Avalanche project? That's a nice general question we'd like to see.
Yeah, it's a tough one for me to say because I don't want to show any favorites. I love all my kids the same. That.
I always have a favorite kid. I
think the Spaces VM, which just launched, go try out spaces.xyz. The reason I dig this is because this is a new subnet and virtual machine. This is not, like I said, this is not a smart contract which is running on the EVM. No, this is an entirely new paradigm. And it's a hierarchical key value store. Key value is one of the most primitive abstractions in computer science, and there have been so many different key value libraries and so many ways to solve that problem. And so it's interesting to me that now we have, this virtual machine which does key value, and I'm really interested to see how developers end up using it in their apps. So at the moment, the one I've got a crush on is the Spaces VM.
Very good. Average cost to launch a dApp on AVAX mainnet?
That's a great question. We have dynamic fees, the IP 1559 style dynamic fees, but it is drastically more inexpensive than what you would do on Ethereum. I don't have the exact quotes, but I would say between 10 and 100x cheaper than what you would do on Ethereum.
Very good. Where should I start? In Web2 Dev, where should I start? What's the first step?
Yeah, so the first step is being here. So the first step is just being interested. So great job. I would say go and check out AvalancheJS. It's the project that I maintain. And that's sort of like the middle ground. So, go fire up our local network, get AvalancheJS, start creating some tokens. So that would be where the rubber hits the road.
Very good. We're trying for one more. What is the thing I should be most excited about as an Avalanche developer in the next 3 to 6 months?
Definitely permissionless subnets. So across subnet asset transfers and being able to fire up your own subnet. So, we've been talking about a Bitcoin virtual machine and a Bitcoin Cash virtual machine and an Ethereum virtual machine. And the problem right now with launching a Bitcoin subnet is that it would have to be permissioned. And as the subnet launcher, you would have to add and whitelist different validators. We don't want that. We want to launch a Bitcoin subnet, which has a Bitcoin virtual machine. So basically script and pay to pub key hash and pay to script hash, all of the stuff that's available in Bitcoin, the Bitcoin virtual machine, but running as an Avalanche virtual machine. So instead of Nakamoto consensus, we have Avalanche consensus. So we're getting thousands of TPS with sub-second immutable irreversible finality. You can use all of the existing Bitcoin smart contract development tooling. We're going to do a UTXO airdrop. So if you have Bitcoin, all of a sudden you'll have an equivalent amount of Bitcoin in this subsystem, and then you'll be able to add as a validator permissionlessly. So I'd say the big exciting things, the things which are really going to kick subnets off, are permissionless subnets and subnet asset transfers.
Very good. There's still people trying to join. They're late to the show. Gabriel, it's been an absolute pleasure. Nice to have 250 keen as mustard people learning the next about all the exciting things they're going to do next. So as ever, my friend, thank you so much for your time. And anyone that's thank you everyone for joining us. More great things will come, more great events. Watch the socials. Something big is about to drop. Watch the socials. That is the alpha leak. Otherwise, you'll get an NFT for joining this event. So keep that. That will mean something, hopefully in due course as well. Thank you very much, everyone, for attending. Gabriel, my huge thanks, and have a wonderful evening, afternoon, morning, wherever you are, guys. See you soon.